Welcome. Here, we break down complex electrical engineering concepts into simple, practical, and engaging explanations. So stay connected with the world of electrical engineering.
Here, we will study the block diagram of a numerical protection relay. This diagram shows how a numerical relay takes the input signals from CT and PT, processes them, and finally sends data or commands through different communication ports. Let us understand each block one by one. The first block is the signal conditioning circuit. This is the stage where the relay receives the AC signals from a CT or a PT. Even the secondary output of CT or PT carries energy, and it cannot be directly fed into delicate electronic circuits. So, the signal conditioning circuit performs three important functions. It scales down the voltage or current to a much lower value, which is safe for electronic components. It provides electrical isolation between the power system and the relay's internal circuits, and it filters the signal to remove noise and unwanted high-frequency components so that the signal becomes clean. After conditioning, the analog signal becomes suitable for the next block, which is the ADC. The second block is the analog to digital converter, also called ADC. The conditioned analog signal enters this block, and the ADC performs sampling. Typically, a numerical relay samples the signal 12 to 64 times in every cycle. This high sampling rate helps the relay capture even small changes in the voltage or current waveform. The ADC converts each sample into a digital number. So now the analog waveform becomes a set of digital values which can be easily processed by a microprocessor. This is the point where the relay moves from analog world to digital world. The third block is the Microprocessor Unit, also known as the CPU of the relay. This is the brain of the entire numerical relay. Inside this unit, various protection algorithms are running. These algorithms calculate the magnitude, angle, frequency, fault current, and many other quantities. Based on these calculations, the microprocessor decides whether there is a fault, whether the relay should trip, whether it should block. Modern numerical relays use advanced 32-bit or even 64-bit processors, so they work very fast and very efficiently. This unit also controls internal communication, data handling, and coordination with external systems. This block is the memory system. A numerical relay uses two types of memory. Volatile memory, which is RAM. RAM stores temporary data while the relay is running, and non-volatile memory, such as flash or EEPROM. These memories store permanent information such as protection settings, configuration, event records, disturbance records, and recorded fault data. Even if the relay power goes off, all the stored settings remain safe in non-volatile memory. The last block is the communication interface. Modern numerical relays have multiple communication ports, which support different communication protocols. This allows the relay to exchange data with SCADA systems, substation automation systems, other IEDS, and control room computers. Through these ports, the relay can send event logs, measurement values, trip status, and disturbance waveforms. Communication also allows remote monitoring and remote settings, which are very important in today's smart substations. After all internal processing is complete, the microprocessor sends the final commands or data through multiple communication ports provided on the relay. These ports help the relay to share information with external systems, making it a smart and intelligent device. So students, this is the complete working flow of a numerical protection relay, CT or PT to signal conditioning, then to ADC, then to microprocessor, then to memory, then to communication interfaces, and finally to the output ports. This combination of hardware and software makes numerical relays very accurate, fast, and reliable for modern power systems. Thank you for listening. We will meet in the next class with another important topic.
Thanks for watching. We hope this video helped you understand electrical engineering concepts better. If you enjoyed the content, don't forget to like, share, and leave your thoughts in the comments. Stay with us and stay updated with more videos on transmission lines, substations, and power systems. Until next time, stay curious, keep learning, and keep the power flowing.